Hello and welcome. Thank you for joining us today, where we'd like to talk about the security implications of this explosive adoption of the public cloud and AWS in particular. My name is Gokul. I'm with Vectra and I'm joined by my colleague, Ben. Together, what we want to go through today is try and understand the pain involved in the security team of organizations adopting cloud and essentially extending their domain of coverage to include this new threat surface. From there, we want to not just talk about, but show you a couple of live examples of how attackers view this cloud AWS attack surface and how they go about their attacks. With that in mind, we then talk about what you can do to stay ahead of the curve on this one, stay ahead of the attackers, and then briefly introduce how Vectra can help you in that journey. So, exciting hour ahead of us. Let's get right to it. This is a phenomenon that must be familiar to most of you in the audience. There's a convergence of two organizational changes and processes that's creating this tsunami in organizations and their security controls. The first is this whole movement of digitization and adoption of the cloud means that ownership for IT is now extremely decentralized. There are dozens, if not hundreds of teams responsible for tiny microservices even that are independently owning not just the build of the application, but also the security, the uptime, the monitoring, the whole lot of it. And then these groups are empowered to make changes at any time in production after testing their bit of the code in silos, right? So together, this just means from a security standpoint, there's a complete loss of control for traditional security teams who previously at any point in time knew exactly what the perimeters were that they had to defend. And then all of the controls that were applied within. So now, when the same security team is tasked with defending the cloud, these are questions that we hear from our customers time and time again. I don't know how many accounts or regions my application is spread across. I don't know what cloud services I'm using at any point in time. There's over 200 of them available and at our disposal. I honestly don't know who is authorized to make changes in in these applications at any point in time. I know there is one identity source. What about the others? I don't know all of the connections into the cloud at any point in time. This includes, VPNs and direct connects from a data center. This includes third-party SaaS services that are being leveraged by the cloud application. There's often dozens of these across the application stack, right? So this is essentially, you just no longer know what you have to protect. And then on the other hand, because of decentralization, the standard set of recommendations that a security architect provides are not necessarily enforced. You've got application teams building what they thought was the most optimal for high performance, great scale, and lowest cost. But the security requirements got left by the wayside. Oftentimes, all that you have is a least common denominator to meet some kind of compliance bar, but that's not enough, right? That's not enough to stop an attack of even moderate sophistication, right? So question, if you feel this way, are you alone? Certainly not. So there was a recent survey where of cloud executives and essentially, this includes digitization, this includes VP of Cloud, this includes CISOs, and 86% of the respondents felt like they have not mastered security and compliance in the cloud. So how do attackers then take advantage of this? The easy progression is, you have a data center. That's easy to understand. And the data center has specific channels to talk to the cloud. This is typically a VPN. This is some kind of a access or a route into the cloud. Direct Connect is another popular service. And then essentially the cloud is an extension of the data center, typical of lift and shift adoption of the cloud. So an attacker may begin in the data center, migrate into the cloud. What we found is this is very rare in the wild. There's one group, the APD10 group, which didn't exactly go after AWS, but was able to execute this kind of attack. That's over 5 years ago now. And we haven't seen a resurgence of this. On the other hand, move to the right side of the screen, what is becoming increasingly common is control plane attacks. So this is where everything in the cloud is about services talking to each other using authenticated, authorized API calls. Right? So if an attacker manages to breach that line of trust and essentially get credentials from either in the cloud or compromise credentials outside the cloud, they get in, and at that point, they have just access to any of the services that credential is authorized for. And this is where there is a long and ever-growing list of breaches in high-profile organizations. So the right side is an increasing area of focus for defenders as well. To give you an idea, this is a company that we deployed into, and essentially they were experiencing an attack. This attack began with the attacker compromising and essentially getting credentials out of their e-commerce mobile app, and then using those credentials to then talk to the server side of the application, which was hosted in AWS, right? So they were able to progress, they were able to discover what else was deployed, and they were able to escalate privileges to do more, so far as get to the key store for the organization, at which point they were stopped because we saw all of those attack steps in the progression early enough. But this is an example of how an organization can be attacked through the control plane. So the key features of such attacks are oftentimes it begins outside the cloud. It could be static credentials in code repositories. It could be a spear phishing campaign on email, which then compromised the identity in the provider and then moves in using single sign-on to the cloud. It could be a client-side vulnerability like you just saw. Beyond that initial compromise, the attack just leverages very native features and APIs. So this is, as living off the land as one can think of. And the progress is fast and impact is big, because once you've got the permissions, you can move through a lot faster. There is no going and finding the next vulnerability in the next resource you want to target. You're just using documented APIs. And typically, given how elastic clouds are deployed, you have multiple you've got multiple data stores, you've got redundancy in all of those. And so if I want to impact with those same credentials, the impact is much larger. Ben now is going to walk you through one such scenario.
Thanks, Gokul. So before I start the attack, I want to review our attack scenario here. So we have a developer. Any developer has a code repo. Inside that code repo, though, the developer accidentally or purposely has a set of credentials. One day now we have an attacker poking around, and the attacker finds those credentials in the code repo. The attacker then takes those credentials and plugs it into Pacu, which is a exploitation framework for AWS created by Rhino Security Labs, and also plugs it into AWS CLI. Now what happens with that is they can start doing discovery against the environment or that company's infrastructure into AWS. Through that, the attacker finds that the credentials they have found has the ability to list roles in AWS and assume roles in AWS. Through the discovery of that, the attacker finds that one of the roles they can assume is the Lambda manager role. The attacker then creates a new Lambda function, and that Lambda function creates a backdoor to a command and control server. And what the Lambda function is doing is monitoring new user event creates. So now when the admin comes in and creates some new roles inside the AWS environment, the attacker intercepts those roles and establishes persistence into that environment. Okay, now I'll go ahead and perform this attack live. Okay, so I've logged into my console here. I have a shell script, and this shell script is again running Pacu and AWS CLI commands. So I'll go ahead and start the attack. So as we discussed earlier, the attacker has found some credentials. In this case, they belong to chriswebb@example.com. And they are going to plug those credentials into Pacu and AWS CLI. So first thing they're going to do is set those credentials up. Now that the credentials have been set, the attacker is going to start their initial discovery to discover information about the AWS account that they have. Here you can see we were able to pull the account ID, the alias, but we've also been blocked for things like the account spend. So now the attacker is going to perform more discovery. Again, this is through Pacu. It's a built-in module within Pacu to do these discoveries. Okay, we can see here that we started having access to some users and role policies through Pacu. And now the attacker does a who am I on their specific user. And here you can see their username is chriswebb@example.com, and their account ID is this, or sorry, their user ID is this AIDA number. So now the attacker is going to start listing other policies. Since they have access to list policies, the first policy they list is going to be their own. And here you can see where the attacker found they have the ability to assume roles and list different roles. One of the additional roles they found was this Lambda manager policy. And in here, we can see the actions they have are for Lambda, and that is allowed. So now the attacker with that ability to list has been able to go through all the different roles and find one that has this Lambda manager role. So now the attacker is going to assume the identity of Lambda manager, or sorry, assume the role of Lambda manager since they have that ability. And the attacker is going to start doing their discovery again. This is the same discovery they were doing before, but that now they are doing it as the Lambda manager role. You can see some of our permissions changed here because now using the Lambda manager role, they don't have access to list those roles anymore. But the attacker performs a who am I again. And now we can see that the ARN, for instance, has changed to this Lambda manager role web Lambda manager. And the user ID has also changed to one that reflects Lambda manager. So now the attacker is going to start looking at the Lambda functions and do discovery on Lambda. So what we can see here is the attacker was able to find existing Lambda functions that were in the environment, but they also did this across multiple regions. So you can see this happen in US East 1, as well as US West 2. Now the attacker is going to create a new Lambda function, and this Lambda function is what is going to go to the attacker's command and control server. So now the new function has been created, and this is going to watch for those new user creates or new role creations. So now every time a valid AWS admin comes in, the attacker is automatically going to get those permissions to their command and control server. So I'm kind of switching roles here a little bit. Now I am a AWS admin, so I am stepping out of the attacker role for a minute. So now my AWS admin is going to create a new role for S3 admin and a EC2 admin role. So we can see here I created an S3 admin and an EC2 admin role. And again, those were intercepted by the attacker through their backdoor. So now the attacker is going to use those credentials to start doing a discovery. So now we are assuming the role of the S3 admin, again, doing a discovery through Pacu to see what we have access to while we're using this role. And we see here we found some permissions to S3. So now we'll just do a simple AWS CLI to list the S3 buckets in this environment. And here we can see we have all the S3 buckets. And we would also be able to sync these buckets, meaning we can do a data exfil and steal the data inside these buckets. Now let's go ahead and switch over to the EC2 admin role. Again, the attacker is going to do some basic discovery with Pacu to discover what they have permission to. The discovery has finished, and in this scenario here, we see the attacker has access to EC2. So now the attacker is going to be able to describe all those EC2 instances in the customer's environment. And here you can see the describe instances that are in this AWS organization. So that's it for our attack. So the attacker has been able to take a set of credentials with minimum privileges, use those credentials to then create a new Lambda function that establishes that persistence, and then through establishing that persistence is able to intercept other roles that have been created. And now the attacker can do anything in the S3 environment or the EC2 environment, and with the previous credentials or the Lambda environment in this organization. So from zero, just finding those credentials, to basically owning anything of importance inside this AWS organization. So that's it for the demo. Go ahead and switch it back over to you, Coco.
Thanks, Ben. So just to be clear, the tool that you used is nothing special. It's essentially a framework for automating standard AWS API calls. Is that correct?
That is correct. So we went directly against the AWS API, did nothing on the network side, and we're able to go take over the control plane in that customer or organization's environment.
And going forward, essentially, over a period of time, the attacker will have credentials for nearly every role that organization's AWS has users for.
That's correct. So anytime a new role is created or new users created, that attacker is going to intercept those roles, and
including administrative users.
Yes, and be able to have those. If they don't notice this for a week, a month, then those are all now compromised keys and credentials.
And once the Lambda is there and doing what it does, after that persistence has been established, there's almost no sign of ongoing activity. It just comes up, on a trigger when a new user is created and just vaporizes once it has shipped those credentials out.
That is correct. And even if the original user disappears, that original developer, they will still have persistence with the other remaining credentials they've stolen.
Unbelievable. So then that poses the next big problem for us defenders, which is what are approaches that one can take. The traditional approach has been one of prevention. In theory, you could have locked down, using static code analysis, ensured that no credentials ever got left out in the wild in code repositories. And then you also have to ensure that spear phishing never succeeds. A lot of never ever statements there, highly unlikely to succeed. The next is you say, I'm going to wrap a tight bubble, get every IAM policy airtight. And so there are like zero cases of excessively permissive roles. Now, an organization that we've recently deployed into has 95,000 users, principals, and about over 1 million role assumption events in 2 months. What's the likelihood of a security team being able to ensure there's not one additional permission there granted to a user that they should not have? So, this preventive approach is good for, making sure there's basic hygiene, things like no S3 bucket is exposed publicly, those kinds of things. But it's not tailor-made. It does not understand the organization's application stack enough to stop attacks that look for those gaps in permission. The other approach, which is more of a legacy from the past, from the data center world, is more of a hunting approach, which is get all the logs into one place, and then I will, look for evidence of attacks in that. There are limited model building capabilities in these data lakes. They're meant for just consuming large volumes of data as opposed to looking through it insightfully. And the investment you need to stay up to date on that is very expensive. And all this for what? You get a signal once you start hunting. At that point, it's too little, too late. So really, the only option is active threat detection. So the idea is that the security team has something they can deploy very quickly and independent of developers, just watching from the sidelines, collecting reliable set of data, and just looking for activity without necessarily depending on developers to do something to enable them. Right? So no agents, none of that. Just sit on the sidelines and watch. So now, what are those options when you think about threat detection? If you say active threat detection is the only option to solve, to get ahead of such a problem, then in the example we saw, it means as soon as that Lambda, there are sort of the escalations of privilege and lateral movement and that new Lambda getting deployed, somebody knows it's part of an attack sequence and alerts you to it. So traditional CSPMs claim to do some threat detection, but they're not really looking for anything sophisticated. They're looking for some basic excursions from the norm, not terribly helpful. And they'll typically tell you each time a new bucket is instantiated, for example, right? So they're not the specialists at that. Leave them aside. They have their own use on the posture side, but not a substitute for threat detection. The native cloud service provider provided tool currently looks for just attacks on 4 services. Over nearly half of them are simply threat intel matches to a malicious domain or IP, and the rest are baseline anomalies. Right? So there are other platform limitations, like it's siloed by AWS region. Many organizations have operations in a dozen AWS regions, and as a user, you just toggle one setting on the UI, and you're suddenly deploying resources in a new region. So you cannot be siloed in your view by region. And of course, attacks don't start and end in AWS. They start oftentimes outside and come in. So that's where our approach shines. And so here as Vectra, we have over 24 AI detections of attack behavior that cover a dozen services that we've determined are part of a threat vector. And so the outcome is you have very high confidence alerts, which means you can remediate automation or automate remediation without breaking or causing collateral damage. Prioritization is key, and we do a great job of that. And we also provide integrated investigations, so you're not going through 3 different services to connect the dots. So that, in summary, is what Vectra Detect delivers for protecting your AWS control plane. So there is a portfolio of detections. Each of those gets attributed. And this is a very complex problem to solve, attribution, because to go from the assumed role back to the principal is a multi-hop connecting the dots, and then prioritization so that you know exactly what you need to go tackle first. Like I said, integrated investigation brings all of the data to your fingertips. So then your remediation can be very high confidence. All this is delivered as a SaaS and can be set up in minutes. So Ben, I've waxed eloquent about why threat detection and response is your only reliable option, and briefly talked about why Vectra is the best choice for threat detection and response. But of course, the proof of the pudding is in the eating. You just demonstrated an attack. Why don't you talk us through what Vectra saw?
Sure, thanks, Gokul. Okay, so I've logged into our Detect for AWS console here. And as you can see here, I've detected an account. I've detected that Chris Webb at example.com as being a threat using AI and machine learning. Now, what you see below here, these are the different detections that we actually set off. And you'll see the correlation between these detections and the attack that we performed in the previous example. So we have our AWS organizational discovery as our first attack that we did, or when the attacker was looking at the organization. Here you can see the events that happened within that particular detection. So we can see my list account aliases and my describe organization. That's where I was able to pull up the name of our organization, as well as the source IP addresses it came from. If there was any roles assumed, they would show up in this column. Now, on the left-hand side, though, I have a nice little summary of everything that happened. I can see the different events that happened, the number of occurrences, as well as the source IP addresses that the attacker was using. A lot of times an attacker is going to try to mask or hide themselves behind a VPN or some type of proxy. Here you can also see if any roles were assumed and the user agents being assumed by that particular attacker and in the AWS region. So you can get a summary of everything that happened in this detection. Now, as far as further investigation and detecting here, we have this AWS Lambda hijacking. So remember now, This is our attacker first used that Chris user and then was able to find the Lambda manager role. And now we can see over in my, under my events here, I have this Lambda manager role web, because now that has been assumed by my attacker. So now here we're starting to see that entire role sequence together. And in fact, if I drop this down here under my role sequence, you can see my Chris web at example.com was going through Lambda manager role web when they created these functions. So now I have my principal as well as the assumed role. If you do not necessarily understand what this detection was, we have these quick little one-pagers here on all these detections. You can go ahead and press this question mark, and it's going to describe what this is. So, you know, anytime a new one may happen in your environment, you can quickly go to this page and see what the triggers were and some possible root causes, as well as a link to the MITRE attack framework here. You can go ahead and click this hyperlink and it will take you to the MITRE page on that. Now, as far as the attacker moving between different regions and assuming other roles. So now I'm looking at the AWS S3 enumeration. So this is when the attacker started acting as the S3 admin, but the attacker also looked at the buckets in multiple regions. So here we can see on my summary that the attacker hit US East 1 and US East 2 when they started doing discovery for the S3 infrastructure for that organization. Now, we've kind of manually, clicked all these different detections. We can go through the events and see what happened in this event to see the request parameters. We've been manually looking at the regions and then those affected services. We also have what we call incident investigation, and that is going to pull all this data together. So any of those questions that you're looking for are already going to be answered under incident investigation. So here I can see these services that were changed, right? I can see that Lambda function, like that something happened. This attacker created the Lambda function. I can see the different regions that were affected by this attacker, any number of actions in each one of those regions. I can also even drop this down to see what those actions were performed in each one of those regions. Below that, I can see the different roles the attacker assumed and the number of times the attacker assumed those roles. So here I have that Lambda manager, and then I have the S3 admin and the EC2 admin. If the attacker did log into the actual UI, I would be able to see that here. In this case, we did everything through command line, again with Pacu and AWS CLI. And below that, any other activity that the attacker has performed. So now I can see all the EC2 actions that were performed, the Lambda, the S3, any IAM or organizational type information that didn't fall above here. So as a security analyst, I can quickly and easily go in here and see what the attacker did and who they did it as and in what regions were active. And now I can go ahead and start locking down and mitigating whatever this attacker did in this infrastructure. So that's it for the demo. I'll go ahead and pass it back to you, Gokul.
Thanks, Ben. So that's wicked. So basically in one console, without having to go to any other service or product, I get my signal, I get reasons for why that fired, I get detailed log level actions that contributed to that behavior being classified as malicious. And then I get, with that instant investigation, I also get to know what else that attacker has been touching, which may still not have risen up to the level of an attack detection, but it's just a ticking time bomb.
That's correct.
Awesome. So is that just a lab exercise? Absolutely not. we have a number of real world case studies now on our website where we've helped organizations thwart active attacks in their cloud. So the question then obviously that arises is, what does it take? Is this one of those, hey, put an agent on everything, go turn this on, that on, and the other? The answer is no. We've had organizations deploy coverage for over 300 AWS accounts within a couple of hours. And this is because AWS CloudTrail logging is just simply recommended best practice. You turn it on at an organization level, and it automatically gets turned on at every individual account that's part of that. And then in order to activate the Vectra coverage, it is simply sign up for a Vectra SaaS account, and in AWS authorize Vectra to pull logs, the CloudTrail logs for your AWS organization. Once that's done, Vectra takes it over, essentially analyzes activity, assigns, attributes it to specific perpetrators, gives you prioritization, the tools to investigate and resolve. And now we also have the ability to automate actions using APIs. So this, A, it's super quick to turn on, and B, it should fit like a glove right into the rest of your existing SOC practices. The examples below just give you an idea of what it takes to operationalize it and what an ongoing workload would look like. There is no ongoing tweaking, tuning, model building, rule keeping exercise here. This is all behavioral models that you do not need to touch. You feel like you've seen some good stuff. You want to, figure out more. We have plenty of resources. The attack that you saw and Ben demonstrated is something that you can try out on your own in your AWS sandbox, right? So reach out to your Vectra team, let us know. We'd be happy to share the code that was the scripts that were used to execute that. And also, again, like Ben said, it's all just existing off-the-shelf free open source tools. So we'd be happy to guide you through that. And yeah, you could sign up for a free Vectra eval and just see how it works. As far as should you choose to make the decision to add this to your portfolio of Vectra products, you could get it either through the marketplace or your preferred partner. So just any questions, get in touch with your Vectra team today, and we'd love to help you out. So that's all from Ben and myself today. Thank you so much for your time, and we look forward to moving security forward.